In this video I will talk about greenhouse effect and global warming. Greenhouse effect is a natural thing. Without that, life on Earth would not be possible. It is a superset of global warming. What do I mean by it? Let's consider this as the surface of the Earth. And let's say that this is the atmosphere. It has a lot of gases. In the daytime, short wavelength infrared radiations enter Earth, and they are entering Earth without a problem. Now there are certain gases in our atmosphere. They have such an absorption spectrum that during the night, when long wavelength IR is re-emitted into the atmosphere, these are long wavelength IR and this was short wavelength IR. So when this long wavelength IR is re-emitted, they absorb it, and by thermodynamics we know that good absorbers are also good radiators, so they radiate it back to Earth. Now if they wouldn't have absorbed it and allowed all the long wavelength IR to leave the atmosphere, then we would have had a very cold atmosphere. On the other hand, if a lot of this long wavelength IR is re-radiated back to Earth, then there will be warming, sort of global warming that we are seeing. Therefore there has to be this delicate balance. A little bit of IR has to be reflected, little bit of IR has to be reverted back. Moreover, another balance is during insolation or incoming solar radiation. When this thing happens, some amount has to be allowed to go in, some amount of this IR has to be reflected back. This is called albedo. Now I have told you that there are some gases which cause this greenhouse effect, and there are some other gases which can also do the same thing. They are called the climate forces. These gases are called climate forces. Why? Because they do this phenomenon called radiative forcing. Radiative forcing means that the incoming wavelength is blocked to a different level, the outgoing wavelength is blocked to a different level. This differential blocking of different wavelengths of the same light results in either warming or heating of the system which is contained within. This is called radiative forcing, and these forcer gases do this job. So this is greenhouse effect. Perfectly alright, quite natural. That's how life is sustained on Earth. But I have talked about the fact that an imbalance can cause global warming. Let us first understand what are the gases in our atmosphere. First of all, 78% is nitrogen. About 21% is oxygen. None of these have any role to play in the greenhouse effect. Then about 0.04% is CO2. This has a role to play. 0 to 4%, much higher than CO2, is water vapor or H2O. Depending on the humidity, the temperature of the air, warm air holds more moisture. This also has a very crucial role to play. In fact, water vapor causes 50% of the global warming. And now let me draw the diagram. If I consider global warming as such, 50% of it is caused due to this water vapor, which in all practical cases can be assumed to be natural. The water vapor released anthropogenically is no comparison to that which is released by oceans and through natural sources. Another 25% is by the clouds. Clouds are not water vapor but condensed water around a dust nuclei. So they do the 25%, and the remaining 25% is through a number of other gases, within which I have CO2, both natural and artificial, CH4, both natural and artificial, and other gases. So natural CO2 is from volcanoes, natural CH4 is from peatlands, wetlands. I'm not going to the natural thing. Let me go into the artificial thing. This artificial CO2, artificial CH4 and other gases implies global warming. That is something which is not natural. Now there is a debate that whether global warming that we are seeing is sufficiently contributed by human beings, or is it mostly a natural phenomenon. I will talk about that, and that is also a debatable topic. But I will talk about the artificial global warming that we are seeing, and within that 50% of this artificial global warming is because of CO2 plus some other minute gases, but 50% around CO2. Another 50% is because of short-lived climate pollutants, SLCPs. What are they? Mainly those which have a short lifespan, such as black carbon, which has a lifespan of a few days, HFC, hydroxyfluorocarbon, or hydrofluorocarbon. I'm not talking about CFC or HCFC. They also are short-lived, but they have been phased out. I'm also not talking about water vapor, because water vapor has a lifespan of a few days, but it is mostly natural, so I'm not talking about that as well. Then there is this tropospheric ozone. I will discuss about that, and methane. So it's important to understand their lifespan. For black carbon it is a few days, for HFCs it is a few years, similarly this. For methane it is about 12 years. For everything it is about 15 years, 20 years, something like that. So within a period of 15 to 20 years, if you can phase them out, you will eliminate 50% of all the artificial global warming that we are seeing. So rather than concentrating on CO2, we should concentrate on SLCPs, and it is possible. If we improve our engine design, black carbon can be removed. What is black carbon? Incomplete combustion of fossil fuels. Combustion of organics which are non-fossils is brown carbon. What is HFC? That which we find in coolants and refrigerants. Tropospheric ozone is a secondary pollutant I will discuss. Methane, 40% of it is from agriculture, maximum, even more than the natural sources actually, and about 20-30% is from leakages from natural gas drilling stations, and of course the peatlands, wetlands are also there. Out of all of this, only tropospheric ozone is a secondary pollutant. What do I mean by that? The production of tropospheric ozone occurs by combination of two pollutants from the exhaust of an automobile, nitrogen oxide and volatile organic compounds. When combined in the presence of sunlight, produce this tropospheric ozone, and methane is an important precursor in this reaction, so that if we can eliminate this methane, we will be reducing the production of tropospheric ozone by 50%. It is a very important thing. Methane has no role to play in stratospheric ozone, but tropospheric ozone is bad. It is not just bad for the environment, also for human health. Similarly, black carbon is bad for human health as well. So now another question is that you have talked about the different SLCPs, but what is the global warming potential? The global warming potential of carbon dioxide is taken as 1. So the global warming potential of methane is about 30. Then tropospheric ozone, I don't remember. HFC, it is about 3000. Black carbon is also pretty high, but there are some other minute chemicals which I have not mentioned, and I have not mentioned CFC because it has been phased out. It had a greenhouse potential of about 13,000. I have not mentioned about SF6 because it is very negligibly present. It has a greenhouse potential of about 20,000. So good that we have removed this CFC because of the Montreal Protocol, and if we can remove HFC also as per the Kigali Amendment, then a very good greenhouse potential gas will be removed. The question is, methane has a greenhouse potential of only 30, then why do we see in the news that methane is such a potent greenhouse gas? Because it is the most abundant out of all of these four. Okay, and therefore out of these SLCPs, methane is the greatest contributor to greenhouse effect, not because of the GWP but because of its abundance. It is much lesser than CO2 because CO2 is about 50%. As you can see, CO2 has a greenhouse potential of 1, but still it is a major contributor. If methane increases more, it can overtake CO2 because it has about 30 times greater greenhouse this global warming potential. So this is important. There is another greenhouse gas called N2O that has a global warming potential of about 300. So an idea of this greenhouse global warming potential must be known. So I have discussed about SLCPs. Now let me go to CO2. So in CO2 I want to discuss about, first of all, the total amount of CO2 that is in the earth, because there is something called the carbon budget. We must understand how much is being produced, how much is being absorbed, and there's something called the carbon cycle. Volcanoes produce it, oceans and forests absorb it. The total amount of CO2 that is there in our earth is roughly 65,000 billion tons of CO2 total. Out of this, about 35,000 billion tons are in the oceans alone. Oceans. So oceans are by far the biggest stores of carbon dioxide, and they are also the biggest absorbers of carbon dioxide. Annually, through natural sources, and this is the total store. And now let us study the annual increment, annual production of CO2 from natural sources. It is roughly 100 billion tons. No comparison to what is present as a reserve on Earth, but a lot of CO2. From artificial sources, it is roughly 30 billion tons. And there is a website, I will tell you the name, just wait a second. There is a website called theworldcounts.com, in which you can see the tons of CO2 which is emitted into the atmosphere in this year as of now. By the end of the year you will see 30 or 40 billion tons, but it is no comparison to the natural sources. So it is no comparison to the natural sources. Still we say that this artificial source of CO2 is causing global warming because the balance is being disturbed. Okay, among the artificial sources, energy sector is the biggest source, and within the energy sector, transport is the biggest source. The ships, the aeroplanes, the automobiles. Within the natural sources, you have a lot of sources. Vegetation is there through the respiration, volcanoes are there, many more. And now the absorption of CO2, because if something is produced, it must also be absorbed. The maximum absorbers of CO2 of this 100 plus 30 billion tons is the ocean. This is the highest. In the terrestrial ecosystem, it is the forest, and within forest, the tropical forest, which is the highest on land. So apart from that, huge reservoirs are also present in peatlands, in permafrost, and in underground reservoirs. Because this absorption of CO2 can sort of offset the extra production of CO2, the focus recently has been on carbon capture and storage. That means capturing carbon from the air so that this budget is maintained and unnecessary heating of our atmosphere doesn't happen. So the fact that this ocean takes in carbon dioxide, uses it for the photosynthesis of various organisms, and whatever is remaining goes into the seabed and is deposited. This is called natural sequestration of carbon. Similarly, because of photosynthesis, these forests also naturally sequester carbon. So there is this carbon sequestration which is natural, but artificial methods of carbon sequestration can be achieved using a geoengineering tool, and this is CCS. In fact, I refer to a website and I will tell you the name of that website as well. It is called geoengineeringmonitor.org, and in this website I found a list of certain artificial carbon capture and storage techniques. I will very quickly go through them. One is sulfate aerosol injection. So if you can put sulfate aerosol injection on the clouds, you already know that clouds are present in our troposphere. If you can put sulfate aerosol injection on the clouds, then the albedo of these clouds will increase. In other words, they will be able to reflect the incoming IR in a better manner and cause a global dimming or cooling. Then the second is cirrus cloud thinning. So cirrus clouds are very high altitude thin clouds, and they absorb a lot of this long wavelength IR in the night time. So if you can thin out this cirrus cloud, if you can cause thinning of this cirrus cloud, then it will stop absorbing and it will let out this long wavelength IR during night. So cirrus clouds are organized in a manner that at high altitudes we know that there is a deficiency of dust particles, so there are less number of dust particles and huge condensation happens. If on the other hand you can provide a lot of ice nuclei, then smaller condensations will happen, and as a result the entire cirrus cloud thickness will reduce. This is a very thick cirrus cloud, this is a thick cirrus cloud, and this is a thin cirrus cloud. So just by adding these ice nuclei, you have caused the thinning of this cirrus cloud, and by causing the thinning you have reduced its ability to retain back the infrared radiation at night. Another important method is ocean iron fertilization. Now we already know that oceans absorb a lot of carbon dioxide. So if this carbon dioxide can be increased, then it will be a very great boost to the entire sequestration exercise. How to do that? So scientists have proposed that you put some iron particles, and these iron particles will act as nutrients for the phytoplankton which are living on the surface. These phytoplankton will start growing, will conduct more photosynthesis, and because of photosynthesis will take in more carbon dioxide. If they take in more carbon dioxide, their population will grow, and ultimately they will die and they will get deposited on the ocean floor. Coral reefs might be formed, a lot of possibilities are there, but mineralization of the atmospheric carbon dioxide will indirectly happen because of this. This is ocean iron fertilization, and a whole lot of these phytoplanktons might be created. It can create an algal bloom. So if I talk about phytoplanktons, there are one category is cyanobacteria, which is a bacteria, it's not an algae. It's called blue-green algae, but it is a bacteria. Apart from that, we have diatoms, dinoflagellates, which are actually algae. So they are the primary producers in an ocean ecosystem, and if we use this technique, in fact there was a project conducted by CSIR and the Helmholtz Foundation of Germany, and it was called the Loha FEX. Loha is the Hindi word for iron, and FEX, it means fertilization. But there were a lot of concerns that it will cause algal bloom and environmental disaster, and it was discontinued. But this is the concept of ocean fertilization or ocean iron fertilization. The next technique is called hydrodynamic trapping. So just like natural gas is present in between two rocks, so these are the two rocks, and natural gas is present in between. Instead of natural gas, if carbon dioxide can be present between two rocks, either in the form of a gas or a supercritical fluid, that is called hydrodynamic trapping. Then I come to solubility trapping. If there is some liquid in which carbon dioxide can be dissolved, I mean, just like a solvent is used to dissolve carbon dioxide from the flue gas. So either you can use such a solvent to dissolve carbon dioxide from the flue gas, or you can burn a fuel in a lot of oxygen so that only carbon dioxide is produced. Or you can, even before burning the fuel, convert that into syngas. In other words, the fuel is converted to syngas is converted to methane is converted to methanol, and you can refer to the News and Statics video on methanol economy. So that can also be pursued, and that will also help. And let me also talk about sulfur dioxide in the flue gas. I'll take this opportunity to talk about that as well. See, whenever the flue gas comes out, sulfur dioxide, if you can react it with lime, which is calcium hydroxide lime, it will form gypsum, and this gypsum can have a wide variety of uses. And in my video on agriculture, you will find how this gypsum can be used on the agricultural fields in order to reclaim an alkaline soil, and also for a number of other advantages. So that is another aspect. Plus this black carbon, the fly ash, can be used in cement industry. So a lot of possibilities are there. All of these possibilities can be used to complement these techniques of CCS which I am discussing. Another technique is microbubbles. So ship can actually release, we can have a certain ship, and it can release, as it goes in the forward direction, it can release a lot of microbubbles, and these microbubbles will form a white foam on the surface of the ocean, which will have a high albedo. Now, whether it is feasible for such a large ocean, and it might also decrease the amount of oxygen going into the oceans and adversely impact the ocean life, so that debate is also there. But the question is that I have discussed here that about 100 billion tons of carbon dioxide is produced naturally. 30 billion tons are produced by human beings. So we say that presently we have 0.04% carbon dioxide in our atmosphere. That is about 400 ppm. Okay, 50-100 years back it was 300 ppm. Some people say before the Industrial Revolution, hundreds of years back, it was say 200 ppm. So it has almost doubled. Can it double only because of the artificial sources of carbon dioxide? Because the natural sources are the majority. Even if this 30 becomes 60, the sum will not double, and therefore there is this debate that are the artificial sources of carbon dioxide really responsible for this increase in the ppm of CO2? Well, the thing is that if this artificial source of carbon dioxide increases, say it becomes 50 billion tons, it will create a chain reaction which will amplify a lot of other factors. It will create some warming. That warming will create warm air. Warm air will be able to hold more water vapor, and that water vapor, which is contributing this 50%, will increase. So indirectly there will be global warming. Indirectly, if global warming happens, it will be a positive feedback. More carbon dioxide will be produced. In fact, it has been said that if the temperature of the Earth's atmosphere increases more than 3 degrees Celsius from the pre-industrial times, all of these tropical forests, the boreal taiga, all of these forests which are now carbon sinks, they will become sources of carbon, because their respiration, and when they die and decompose, their carbon emission will exceed the absorption of carbon that they have. So let that situation not happen. Let us approach the entire situation in a very optimistic manner, and let's hope for the best.